Hello, good evening. Thank you for coming. My name is Ricardo. I'm one of the Android engineers at Blablacar. And today I'm going to present the process we went through. Thanks. The process we went through migrating from AutoValue classes to Kotlin data classes. But before we get into the migration itself, let's quickly take a look at what is AutoValue exactly and why do we need it in the first place. So imagine you have the following user class, and that's Java, not Kotlin yet. We can call it a value class because basically what we're interested in is in the contents of this class. So we're interested in the contents of this user. And in that sense, what we're interested in is putting instances of this user in lists and making sure that two instances of the same user, that is a user with the same UID, login, name, etc., they are considered equal. And if we want to do that, there's a number of things we could or should do to improve this class. For instance, we could make this class final and its fields finals as well to prevent unexpected modifications of these fields and unexpected behavior from using this class. But once we do that, we also need a constructor here so we can initialize our fields and give them value. And if we want to be good citizens, we probably also want to annotate fields that are nullable, for example, so that we give the consumers of our class enough information about how to use it. In addition, if we really want to make comparisons of two different instances of this user, if they have the same information, we need to overwrite equals and hash code. Most IDEs today, they provide ways to generate this for us, so there are automated ways to insert this code into our user class. So this is basically like 2 clicks in an IDE to generate this for us, but we still need to do it for every value class that we are creating in our project. Finally, if we, on Android, we want to use it with a parsable, we need to add the implementation for parsable as well. Again, with Android Studio, we can add this directly, so the Android Studio IDE can generate the code for us, but we still, again, we need to do it for every value class that we have in our project. We need to expose the getters that we're interested in, provide for the users. If we want to let the consumers of our class to modify any information, we probably want to add some convenience methods for them to copy the values of one class to another and provide this copy with the modified value. And in the end, we get this huge class with a lot of boilerplate code that is just there to make sure we have a value class that works as we want. So there must be another solution, and that's not all. In our example from before, we didn't validate the non-null constructor parameters. We didn't add a toString implementation. If we're modifying the fields of this class, we have to go through all these methods that were generated and make sure they are still consistent with the behavior we expect from this class. Talking about serialization, if you're consuming from an API and you have this class, you are either going to rely on reflection, which can be slow, or you have to write your own custom adapters to parse this class and repeat this for every new class that you have in your project. So that's where AutoValue comes in, and AutoValue is a library provided by Google. It basically makes easier to create and maintain these kinds of classes. So what it does is generate this code of equals, hash code, and toString for us, and also provide some of these basic checks that we have been discussing. It also has a plugin system for additional code generation. So with plugins, we can, for example, get parsable and JSON type adapters generated for us. And if you go to the this link on the official AutoValue library, they provide this list of advantages of AutoValue over other solutions that provide similar behavior. They also have a presentation where they go into more details. It's an interesting one. It's worth looking at. But basically, AutoValue has no runtime dependencies, so it's all done at compile time. what you're coding as an API, what you're exposing to the consumers of this class is independent of what is happening behind the scenes. So your consumers of your user class don't have to know that this is an AutoValue class. They can just use it as any other normal class. There are very few limitations about what you can do. It's pretty much a Java class. There are a few rules for defining the fields, but other than that, you can add all kinds of Java things you want to it. And there's almost no magic in the sense that the code that is generated is basically standard Java code that is being used in the manner that they were meant to. So our user class now looks like this. You declare it as abstract, you annotate it with AutoValue, and the fields that you're interested in are abstract methods with the name of the fields that you want. You still have to annotate the ones that are nullable with nullable, but basically once this is done, the Google AutoValue library now generates this code for us, which is basically the code that I presented before, except that it now has the no checks for things that are not null, and everything else gets generated, and we don't have to code this anymore. So if you modify any of the fields, the code will be generated again, updated to reflect the changes you did, and this works really well. One addition you have to do now is that this is an abstract class, so you can't use it directly anymore. One thing you need to do then is expose some kind of way to get the instance that was generated for you. So in our case here, we are providing a simple example with a static method that creates this user with just login, name, and email, and we generate the other methods, but that's up to you to provide all kinds of create methods you want. AutoValue also provides a builder annotation you could use to expose a builder to your consumers, to the consumers of this user class. And with plugins, you can get all of the other things that I presented before in the original class. So in our project, we were using these following 3 plugins. The with one is basically a simpler, faster way to have these methods to copy your class with some of the content modified. The AutoValue JSON by Ryan Harter, it generates type adapters for us for serialization. And AutoValue parcel, also by Ryan Harter, generates the parcelable implementation for us. So now our user class needs to be basically added, needs to have basically just this information added to it. So you need to declare that it implements parcelable. You expose an abstract method here with extra info to generate the code here for copying this class with different extra info. And you can return the generated type adapter via a static constructor that you need to set then in your JSON builder. What AutoValue then is doing is with the plugins creating automatically for you 4 different versions of this class, 4 different implementations of this class, one for each plugin. So this is done automatically, so that's the annotation processor during a build process that is generating this code for you. The $3 AutoValue user has the original AutoValue class here with the no checks, equals, hash code, and so on. The $2 AutoValue implements extends from the $3 and add the JSON type adapter implementation. The $1 extends from the $2 and adds the implementation of my with abstract method. And finally, the AutoValue user extends from the $1 and adds the parcelable implementation. So in the end, since one extends from the other, that extends from the other, all I have to do is instantiate a version of this final AutoValue class here that will have then all the implementations that I need. This works great, and so why do I need to migrate to data classes? Because if I'm moving to Kotlin, I could basically convert this class to Kotlin. So here is our Kotlin version of the AutoValue class that we had before. It's pretty much the same. But now you don't need a double operator anymore. You can use an optional string here, and everything else works just as well. Well, the thing is, you're missing out on a lot if you're not using auto classes for this purpose, for the purpose that AutoValue is meant to. Data classes are basically Kotlin answers to these kinds of value classes, and out of the box, it does what AutoValue does as well, but it's native to the language, so you don't need to have an external dependency anymore. So just by declaring data class of the user with these following fields, you would get the same basic compiled version of the AutoValue generated class. In addition, it has a built-in copy function, which can, out of the box, again, replace our with, because you can, with copy, just pass which fields you want to modify and return a copy of it. And you get as a bonus the structuring declarations, which make it easy to assign multiple variables at once, given your an instance of your class. This is very useful in loops or in lambda expressions, and it's just another advantage that you have over AutoValue. In addition, like I said before, you have less external dependencies now. You can get rid of your plugins. You get rid of AutoValue and the plugins. The code is much smaller, so it's simpler, faster to write, simpler to read. You don't have abstract classes anymore that are open, and so less prone to errors there. One important aspect is that you're using less annotation processors during your build process, because you don't need to generate that code anymore. It's all inside the data class, so the build becomes faster. And in our project specifically, we were running into some smaller plugin issues. They are small, but still they add to the list of things that we consider when migrating. So for example, with can become quite verbose, because you need to declare one for each combination of fields you want to modify. So if you want to have a way to expose modifying the extra info and another extra info and email, you need to declare these two functions, two abstract methods, and they have to follow this contract specifically. So you have to have the full name of the field you want to modify, followed by and, followed by the next field, and so on. And in our case specifically, using JSON, we are using a name policy configuration for converting camel-cased field names automatically into lowercase with an underscore separation. So this JSON can do automatically for you, but the AutoValue plugin we were using doesn't support it. So you have to, for every field in your class that is camel-cased, add a serialized name with this serial name version of your field. So in other words, what we're doing is, here's our AutoValue user class, and we are moving from this to this, which is a much simpler, concise way to code and achieve the same thing. Wait, there is a thing here, which is this new annotation there that I didn't talk about before. So parcelize is Kotlin's official support to parcelable. And it's a plugin. It's marked as experimental, although there are no major issues anymore present. We have been using this in production for over 2 months now, I think, even more perhaps. And there are no major issues present with this plugin. There is only a small warning, so it's going to complain that you need to provide an implementation for parcelable if you're annotated with it, but it has been fixed already, and it's going to be released in the next version of Kotlin. You can also, for now, just ignore the warning and leave it there, or use suppress lint parcel creator to get rid of the warning if you want to. One important difference of this plugin over the annotation processor plugins is that this is a compiler plugin. That is, the compiler is going to run your data class with the annotation and compile, including the parcelable code implementation directly in it. So you don't have this extra step of generating source code first and then compile it to then obtain the result you want. This is done directly in one process. And you can see this by yourself. On Android Studio, you can go through these options, and then there is a button, the compile button. And when you press that, you get this is the decompiled Java class version of my Kotlin data class. And you can see it's pretty much the same as before, just that this was compiled directly. There was no intermediary AutoValue implementation of parcelable in the middle that adds to the build process. So here you can see it's again all generated for you. There is nothing you need to do anymore. It's all created automatically and updated when you modify your data class. If you're migrating from Java and you're not doing it all at once like we did, so for us it helped to focus on changing first the AutoValue class and leave as much as possible that was using those classes as it were. We ran into the following smaller issues. They were not a big deal, but they are still there. So copy it doesn't work with just one method in Java. So the copy function in Java will require you to pass all the methods of your class. So what we did was wrap the copy with the original with extra info, but now it's an implemented method that then wraps the copy with the information that we want to change. And finally, it's not mandatory, but because you can access this method via the companion object, but if you're calling this create from any Java classes, it's just more convenient to annotate it with JVM static, and then your Java classes will work just like before with the AutoValue classes. Just a minute. So far, we have our data class with a parseable implementation, but serialization is still done using reflection if you're using JSON, which we still are actually. And so JSON, you probably all know, it's there for many years now. It's well known. It's versatile. It's very powerful. You can customize it in many ways. But it also has a lot of defaults that can cause problems. So the date adapter, type adapter is broken if you're using out of the box. It's not going to work in most cases. And it has a lot of other little quirks. So we have a more powerful alternative, Mochi, which has been there also for a little while. It's faster than JSON, and it doesn't have all these little issues that JSON has, but it's less configurable, which can be a plus or a minus depending on how you look at it. For us, it was a minus because with JSON we have some very customized type adapters, and also the field name policy that I mentioned before, which Mochi doesn't support. So that means all those automatic conversions that we were getting with JSON from camel case fields to the lowercase ones with the underscore in the middle, they would be gone if we change it to Mochi, and we will need to declare it on a per class basis. In addition, if you're just using those out of the box, you're basically typically going to rely on reflection for parsing the result, unless you write the adapters for these classes. So there are libraries to help us with that, and for JSON there is JSON value, and for Mochi there is Kochi. Mochi has actually Kotlin support, but it currently requires Kotlin reflection, and if you do that, it works really well, but it requires the Kotlin reflection library, which adds up to 2 megabytes of code to your project, so to your app, so you may not want to do that. Kochi doesn't require that, so it's an annotation processor just like JSON value, and so it's going to generate type adapters during the build process of annotation processor. So here, if we are using one of these two libraries, we are not getting rid of one annotation processor. We are getting rid of the original one from AutoValue, another one from the parseable generation, but we would still need annotation processing to generate type adapters for us. So here's how JSON value works. It's very simple. You just annotate the constructor of your data class with JSON constructor, and the fields that are camel-cased, if your API is responding with lowercase and underscore in the middle, you have to annotate it, and that's a problem because you have to do it for every field in every class you have. This library in particular has also an incompatibility issue currently with the Parcelize plugin, so they are not working together. We already posted an issue and the author acknowledged the bug. We hope it's going to be fixed soon. Kochi is basically the same. You annotate it with JSON serializable. You have a JSON annotation here to specify your serializable name, and it will generate the adapters for you. There is a more promising solution though. There is a library provided by Kotlin, which is kotlinx.serialization. I'm going to call it kserializer because it's shorter and they don't have an other name other than this, which is quite long, and I hope they have a shorter name soon. It's a recent library is less than a year old. They still have issues to solve. They're working a lot on it. There's a lot of things to iterate, but it's also very powerful. Out of the box, it works just like the others. It still has this issue here, so you don't have a name policy set up. But it has two important differences. First one is that this is a compiler plugin, again, so there is no annotation processing anymore taking place. So this is our user class compiled to Java, and here I'm just highlighting the serializer object that was compiled for us. So this is like the decompiled version of the compiled code. And here is what the compilation process added to our class for us. So it added a serializer object that is then going to be used to serialize or deserialize this class for us. And another advantage is that this is multi-platform. So if you look at the code of the case serializer, this is what is in the common libraries. So you have an interface here with the expect keyword, which is relatively new. And what this means is that you are telling the compiler that this is to be expected by a platform implementation. So if you look at the JVM implementation now of this library, there is an actual implementation of this interface, which looks for the object's serializer that was compiled for us to process the serialization. And if you want an example of all this working, Jake Wharton published recently an app called SDK Search that on Android, it's for Android, so it's Kotlin multi-platform, so it works on Android and as a Chrome extension. And it's basically an app for searching the Android SDK. And it's very interesting because it's using Kotlin multi-platform. It's an example with coroutines and of using the case serializer. He also published a retrofit adapter for serializing out of the box with retrofit. So there's a lot to unpack here. So we have these three different alternatives. Which one to use? All of them have this field name policy issue for us. That's particularly a problem in our case because we had a lot of our classes camel-cased and our API was returning with lowercase with underscore separation in the middle. And case serializer looks very promising. It's multi-platform. It doesn't have reflection out of the box. It's a compiler plugin, and it's way more powerful in the way you can customize your adapters. One problem, though, is it faster? We didn't know, so we used the JMH library, which is a benchmark library for Java, and we cloned this original work by Zach Sweers, which originally compared basically Mochi with JSON. So we cloned it, we converted the model classes to Kotlin, and added the case serializer serialization to it. And the results were not great. So here is the reflection version of Mochi, and you can see this, the higher score is better, and it's basically half the score of Mochi reflection. So that's not even using custom adapters here. And here is from JSON, and here is running it, importing it to JSON. And here it's even worse, like this is 3 times worse. So because of all these issues, our solution for now was to keep using reflection and write custom JSON adapters where things impacted the startup performance, because that's where we saw the biggest hit. Other than that, in most of the app, the performance is, the importance of performance of serialization is reduced by the network calls. So you have the time of the network, and then that's much bigger than serializing and deserializing in most cases. One final word here, the importance of tests for us was very much so the case. While migrating, having tests for serializing and deserializing these classes ensured ensured our our peace of mind. It was very easy to basically just migrate, run the test, and be sure that everything was working well. And the same for our other classes that were using these AutoValue classes that we were then migrating. And so here is some metrics of the final result. We migrated 46 AutoValue classes. So just these 46 classes, they were generating 83 additional classes via annotation processing. And these additional classes were adding 546 additional methods to our project. That impacted a lot the build time. So a clean build now is more than a minute faster. And we did some tests just removing or adding fields from our class, from our AutoValue classes that are now migrated to data classes. And the incremental build time went from 54 seconds to now typically 39 seconds. AutoValue is a compile time library, so it doesn't add runtime dependencies, so APK size remain roughly the same. And we were expecting this. Our startup time increased by a few hundred milliseconds, but we're okay with it for now. We are hoping that one of the serialization adapters that are being worked on will help us improve this and go back to the previous value or reduce it even further. I want to finish with this following conversation that we stumbled upon while preparing for this presentation. We started this migration more than a month ago, but this is from last week, 2 weeks ago maybe. And this is Ryan Harter. If you remember, this is the author of the 2 libraries for the 2 plugins that we were using from AutoValue, saying that he's now happy to remove AutoValue from his projects. So we can only assume he's not going to be supporting those AutoValue plugins anytime soon. And below here is Jake Wharton saying that AutoValue is fine and you can keep using it, and if it works well for you, by all means keep using it. But there is a lot to gain, especially if you're migrating to Kotlin, there is a lot to gain from moving to data classes, and we are very happy that we did. Thank you. No questions? Okay, then thank you again.